Line integrals in vector fields. Find the work done by the force field. F equals s squared I minus syj in moving along the quarter circle given by the vector function r of t equals cos ti plus sin tj, where t is bounded below by 0 and bounded above by pi over 2. So how do we evaluate this kind of line integrals in vector fields? This is the solution. Recall that the work done is given by f dot dr equals integral from a to b f of r of t dot r prime of t dt. We are given the vector function r of t as r of t equals cos ti plus sin tj. Obviously, s equals cos t and y equals sin t. Now, to obtain f of r of t, we are going to substitute s and y into f, which is our force field. So we have r of t to be equals, this is s squared. We plug in cos t there, that will be cos squared ti. The same thing with s and y, that will be product of sin t. That will be product of sin t and cos t j. So now, the next thing to do is to find the derivative of r of t. This is r of t. Now to take the derivative, we have r prime of t to be minus sin ti, and we differentiate cos t with respect to t. We have this plus cos t j. We are already given t to be bounded below by 0 and above by pi over 2. So now we can evaluate our integral, which is 0 to pi over 2 f r of t. You're gonna have cos squared ti minus sin t cos tj dot minus sin ti plus cos tj. We can now take the dot product dt. So we have 0 to pi over 2 cos squared t minus sin t, that will be minus sin t cos squared t. This guy to this guy, we're gonna have minus sin t cos squared t. So adding these two, we have 0 to pi over 2 minus 2 sin t cos squared t dt. We can now integrate by substitution. Let u equals cos t. When we differentiate, we obtain du over dt to be minus sin t, which implies dt equals du over minus sin t. We can now plug in dt here, so we have 0 to pi over 2 minus sin t cos squared t. We have u to be cos t, so we have u squared times du over minus sin t. We have 2 outside, so the 2 remains here. So this guy and this guy goes, so we are left with 2 into 0 to pi over 2 u squared u. So we can now integrate. We have u raised to power 3 over 3, 0 to pi over 2. But don't forget that u is cos t, so we are going to substitute cos t here, so we have cos t raised to power 3 over 3 from 0 to pi over 2. So we have 2 over 3 outside here, cos pi over 2 raised to power 3 over 3 minus, plug in 0, we have cos 0 raised by 3 over 3. Cos pi over 2, which is cos 90, is simply 0. So we have 2 over 3, 0 minus cos 0 is 1, so we have 1 over 3. So when we do the simplification, we have okay, we have taken 3 outside here, so we're gonna have this. So we have 2 over 3 into minus 1, so we have minus 2 over 3. So the answer is minus 2 over 3. So when we evaluate this, the work done by the force field F is moving along the quarter circle, vector function r of t equals cos t I plus sin t j divided by 0 and pi over 2, we obtain minus 2 over 3. Thanks for watching.